All right, going to try to continue with the reading. We're at 13.7 of Shigley's, whatever this book is called, Mechanical Elements, and 10 more sections, I guess. Let's see how much we can get through as fast as we can until it starts getting weird, at least. 13.7 Interference. The contact of portions of tooth profiles that are not conjugate is called interference. Consider figure 13.16. Where do we have that? All right. Consider this figure. Got it? Now, illustrated are two 16-tooth gears that have been cut to the now obsolete 14.5 degree pressure angle. The driver gear 2 turns clockwise. The initial and final points of contact are designated A and B, respectively, and are located on the pressure line. Now notice that the points of tangency of the pressure line with the basic circles C and D are located inside points A and B. Interference is present because, let's see, the points of tangency of the pressure line with the base circles C and D are located inside A and B. Alright, hopefully it'll make sense eventually. I see, let's see, inside A and B. There's A, there's B. Just continue. Just said I wanted to do this quickly. The interference is explained as follows. Oh, okay, that would help. Contact begins when the tip of the driven tooth contacts the flank of the driving tooth. The tip of the driven tooth contacts the flank of the driving tooth. In this case, the flank of the driving tooth, excuse me, this might be loud. Okay, not loud. In this case, the flank of the driving tooth first makes contact with the driven tooth at point A, and this occurs before the involute portion of the driving tooth comes within range. In other words, contact is occurring below the base circle of gear 2 of the non-involute portion of the flank. The actual effect is that the involute tip or face of the driven gear tends to dig out the non-involute flank of the driver. In this example, the same effect occurs again as the teeth leave contact. Contact should end at point D or before. Since it does not end until point B, the effect is for the tip of the driving tooth to dig out or interfere with the flank of the driven tooth. Excuse me, sorry. Where was I? Driven gear tends to dig out the non-involute flank of the driver. In this example, the same effect occurs again as the teeth leave contact. Contact should end at point D or before, since it does not end until point B. The effect is for the tip of the driving tooth to dig out or interfere with, okay, that's what I read, sorry about that, the flank of the driven tooth. When the gear teeth are produced by a generation process, interference is automatically eliminated because the cutting tool removes the interfering portion of the flank. This effect is called undercutting. If undercutting is at all pronounced, the undercut tooth is considerably weakened. Thus, the effect of eliminating interference by a generation process is merely to substitute another problem for the original one. The smallest number of teeth on a spur pinion gear 1-to-1 gear ratio, which can exist without interference, is NP. The number of teeth for spur gears is given by NP equals 2k over 3 sine squared phi times 1 plus root of 1 plus 3 sine squared phi, where k equals 1 for full depth teeth, 0.8 for stub teeth, and phi equals the pressure angle. For a 20-degree pressure angle with k equal 1, NP equals 2 times 1 over 3 sine squared 20 times 1 plus times 1 plus root 1 plus 3 sine squared of 20. So that's just plugging into the variables, the things that we just agreed on. K equals 1, because we have full depth teeth, pressure angle of 20, and there you go, you get 13, let's see, 12.3. Okay, so they say 12.3 equals 13 because, you're not going to have 0.3 teeth, so you round up to the next one, because we're going for the minimum, right? Because as we say, the smallest number of teeth. There we go, minimum. Thus 13, let me check that, let me see if I can pause things. Let's see, Control S.